My name is Aram, and this presentation is part of my PhD thesis in Auckland University, and it's about a new procurement method for process improvement when it comes to BIM, building information modeling, and it views everything from the perspective of an architect. And it's happening within the context of a facade retrofit. But at this stage, because I'm just at the primary stage of my thesis, it just involves some key strategies for BIM model development when it comes to application and implementation of this new procurement method, namely design for manufacturing and assembly. During the design and selection of manufacturing components for facades, architects tend to avoid single manufacturer for various reasons, mainly to allow the contractor to bid for alternatives. And this leads to a break in data chain from design to installation of products and components when it comes to facades. And it's a waste of time because changing design 3D models and fabrication drawing and design drawing just it's a waste of material and cost within a project. And today we all know the value of design when it comes to construction projects, integrated project delivery, for example, managed to reduce the cost and increase efficiency, decrease material waste within the project just by putting more emphasis at the stage of design. And this is as opposed to the conventional design system where the most effort is at the stage of construction, where the time of changes is past and it would be costly to go back and change the whole fabrication drawing and design drawing and everything. So a desired facade design, because I'm talking about facades, is highly unlikely to be achieved just by following the conventional system. And as we all know, facades are the most complex part of a building because of many reasons, environmental considerations and many other reasons, structural, and designing the facades following this conventional system is just may produce drawings that lack considerations for manufacture and assembly. Design for manufacture and assembly, DfMA, provides way to facilitate manufacture and assembly within a project and contributes to a minimization of cost and delivery time with high quality project delivery and customer satisfaction. And if properly applied to the facades, it has great potential to produce design that supports manufacturing and assembly. And a way to adopt DfMA within the project properly and effectively is through BIM, Building Information Modeling. I'm going to show some key BIM strategies to adopt DfMA within projects and some benefits of adopting DfMA as opposed to conventional design system in Auckland, where my case study is. DfMA as a design concept could be understood as a combination of two methods, DfM, design for manufacturing, and DfA, design for assembly. DfM emphasizes ease of manufacturability, and DfA fulfill the requirements for assemblability. And these two, manufacturability and assemblability, support technological feasibility of components, their installations, and their assembly process within projects. Application of DfMA-oriented design in construction when it comes to literature is mostly related to some other concepts such as concurrent engineering, lean construction, knowledge management, suitable procurement method, and buildability. But the key point in application of DfMA is to bring the knowledge of construction into the design process and use it at earlier stage of design. In this case, knowledge of manufacturing and assembly. So just like the integrated project delivery, or in line with the requirements of integrated project delivery, it puts a great emphasis on earlier stage of design. Empirical studies on design for manufacturing and assembly suggest these principles for its implementation. For example, in a project where a light bulb was used, reducing material cost, minimizing complex operations. But in general, these requirements, if I want to summarize it, includes minimizing manufacturing cost by use pre-assembled modules, minimizing assembly and transport costs, minimizing the number of parts, simplifying the fabrication and assembly steps, using standardized and common components and materials. The size and weight of components should be easy to handle, reducing fastening and jointing steps and things like that. But how can BIM model content be developed to implement this design concept, DfMA design principles, and integrate facade design to manufacture and assembly? The principle of LOD, level of development, is to show the information that a model must contain at different stage of design. So when it comes to literature, LOD can be used as a measuring item to assess a project at different stages of model development within a selected case study compared with the requirements of a DfMA-based process. For example, within this diagram, the green one where just BIM is used, and by BIM, I don't mean BIM level 2, at different stages, different LODs, and we can compare the requirements that fulfill LOD target at different stage within a DfMA-based process, where it's shown by the red color. Yeah, and these are different level of development for facade design stages, different requirements to successfully implement DfMA within a BIM process. A conventional facade design, based on the information that I gathered so far by interviewing industry experts in Auckland, where the dominant system of design is design build. This diagram shows this conventional process. First of all, the design engineers develop design of drawing, develop design and construction drawing of facades, and then deliver these drawings to a contractor. But this delivery is often through a client, through a third party, not through the original engineering company. And the contractor evaluates the drawing, fabrication drawing, design drawing. If any design changes are needed, they will return the drawing to the original engineering company. If no, they will pass it to the manufacturer to go for the manufacturing of components and products. And the manufacturer further evaluates these drawings. If if any changes are needed, they will return the drawing to the original company. If no, they will proceed to the production. And this is obviously a linear process, and in all interviews, my interviewees explained it as what is confirmed by literature. They call it an over-the-wall practice, where engineers threw the problem, unsolved problem, to the manufacturer, and obviously changing design happen frequently, which is costly. In a DfMA-oriented design process, architect, cladding specialist, manufacturer, and contractor all work together, and early involvement of these specialists at the earliest stage of design and model development is shown through the diagram like this. At the stage of project brief, where the basic strategy for implementation of DfMA will be defined, BIM strategies to facilitate DfMA will be identified at this stage, level of resolutions, type of data to be built into model, and many other considerations. In the conceptual phase, project files are divided due to different considerations, for example, size of data for architectural projects, and all files are linked but exported to IFC for file delivery using different kinds of software, in this case Revit, Dynamo, Excel. And different file types will be defined. For example, these types of placeholder for conceptual phase, or this one, the isolated model for each discipline, or the module model, or isolated model, discipline model, and different types of model. I mean, a strategy for development of this model will be defined at the stage of concept, and it will proceed to the detailed design, where the delivery of parametric components will be developed with different levels of detail. Clash detection will be performed at this stage, but it will be developed bearing in mind that it needs to fulfill the requirement for DfMA, which can be defined by three characteristics that DfMA is identified by: that modularity, standardization, and repetition. To legitimize the buildability of components, early involvement of supplier are essential, and after identifying modeling strategy and process development objective for the whole project, component families of parametrically editable and nested families will be developed at this stage for facades. For example, here where this vertical element of a component is specified based on certain considerations, and here where a nested family for window is extruded into different parts. And finally, the and this is the grid and file structure for detail stage. And finally, the stage of pre-construction, where detailed information will be validated and tested through digital prototyping. Files are being exchanged between different software, and this is the final outcome. And these are the parametric items, which is through it can be done through different software for digital prototyping, but in this case it's Autodesk Inventor. Yes, and this way, this was the process of developing models in BIM when it comes to DfMA, and this way we can assess every project, the model development process, for example in a case study, and compare it with requirements that fulfill considerations for design for manufacture and assembly. This is what I've done so far.